Hello. In this video we are going to learn how to draw the VSEPR predicted geometry of SF6. First thing we need to do is a Lewis dot structure. We need to know what types of atoms we have. We have sulfur, we have fluorine. Sulfur is going to give us 6 valence electrons. Fluorine is going to give us 7 valence electrons. We need to figure out how many total valence electrons we have. We have 1 sulfur giving us 6 electrons plus 6 fluorines. Each of those gives us 7 electrons. 42 plus 6 is 48 total electrons. We need to place the least electronegative atom in the center. That's going to be sulfur. Fluorine is the most electronegative atom, so we're going to put sulfur in the center. We're going to draw out 6 bonds here in a kind of a spoked wheel fashion. We're going to put fluorine on the end here for all of these. We had 48 electrons. We just made 6 bonds. Each of those required 2 electrons. 48 minus 12 leaves us with 36 electrons, just enough electrons to fill out all of our octets on fluorine. Like that, and that's all of our 36 electrons. We've done all of them. We have full octets for fluorine. Sulfur has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so this is a hypervalent compound. I'm going to do one extra thing that isn't in the question, but is something I'm going to want you guys to be able to do. And I want to draw out the bond dipoles for each of these. So every bond between 2 atoms where there is any difference of electronegativity is going to have a bond dipole. And that bond dipole is going to point along the bond from the less electronegative atom towards the more electronegative atom. Okay, so we have a difference of electronegativity here. We have a bond. We're going to have a bond dipole that points towards fluorine in each one of these cases. So those are all of my bond dipoles. Now, if I want to figure out the VSEPR structure, the first thing I need is to figure out 2 things: the steric number and the number of lone pairs on the central atom. Okay, the steric number is going to be the number of lone pairs and the number of atoms bound to the central atom. So the central atom in this case has no lone pairs, but it is bound to 1, 2, 3, 4, 5, 6 different atoms. So its steric number is going to be 6, and its lone pair number is going to be 0. Now, based on this information, I need to come down here and take a look at this chart here from chapter 7, section 6. This is the number of electron regions is what I'm calling the steric number. So we need to come down to 6, and then we need to come over to the one that has 0 lone pairs. Okay, so everything with a steric number of 6 is going to have an electron geometry of octahedral, just like everything that has a steric number of 5 is going to have an electron geometry of trigonal bipyramidal. But in this case, where we have 0 lone pairs, the molecular geometry is also going to be octahedral. So all I need to do is look at this image here and then translate that up there and interpret it for my case. So I have the central atom here, dashy, 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 wedge, wedge, straight, straight. We'll come up here. And we need to interpret that for this. So we're going to put sulfur in the center, straight, straight, fluorine, fluorine. These dashes indicate it's going into the plane of the paper, like away from you. It's like an attempt to make perspective. And these wedges here are going to indicate something that's coming out of the plane of paper towards you. And we can label this with an electron geometry of octahedral. And again, anytime we have no lone pairs on the central atom, the molecular geometry is going to be the same as the electron geometry. And it's also going to be octahedral. So that's it. That's our VSEPR structure.